Today, we're heading into the world of quantum computing and the idea of parallel universes.
Oh, this will be fun.
Yeah, and specifically, we're going to be looking at Google's quantum computer Willow, which just did something pretty amazing.
It did.
Yeah, it tackled this thing called random circuit sampling.
Right.
And get this, it did it in minutes.
Yeah, minutes.
And for comparison, like the classical supercomputers, the massive ones, it would have taken them septillions of years.
It really shows you the power of these quantum computers to solve these problems so quickly is really remarkable.
Yeah, it's crazy. But what's even more interesting is this has kind of reignited this debate about could this be evidence of computation happening across multiple universes?
It's a question that a lot of people are asking, especially Hartmut Nevin, the founder of Google's quantum AI team.
Yeah.
He's suggesting that what Willow did gives more weight to the multiverse theory.
Okay, but before we dive into parallel universes, can we just break down what random circuit sampling is and why solving it so fast is such a big deal?
Yeah, so imagine you have a bunch of coins and you flip them randomly.
Okay.
Random circuit sampling is kind of like that, but instead of coins, you have qubits, which are the building blocks of quantum computers.
Okay.
And these qubits can be in multiple states at once, right?
Yeah.
Unlike a coin, which can only be heads or tails.
Right.
The challenge is to predict the probability of getting a specific combination of heads and tails after you flip them randomly a bunch of times.
Okay.
And it's really complex, and it gets harder the more qubits you have.
So essentially, Willow just like cracked this code.
Yeah.
That would take classical computers forever to solve.
Exactly.
And because it did it so quickly, it's leading scientists like Nevin to think maybe it's using power beyond our own universe.
It's very possible, yeah.
So how does this tie into the multiverse theory? I'm not really sure I totally get it.
So the multiverse theory basically says that our universe isn't the only one, that there might be a ton of other universes out there, each with their own laws of physics and possibilities.
Yeah.
And this idea is rooted in quantum mechanics, specifically the many worlds interpretation.
Okay. Many worlds interpretation. What's that?
So basically, every time a quantum event happens, the universe splits.
Okay.
And it creates a new branch of reality for each possible outcome.
Oh, wow.
You can think of it like a tree branching out.
Okay.
And each branch is a different universe where a different possibility happened.
So are we talking like alternate timelines within our universe or separate universes entirely?
Separate universes.
Okay.
Each with its own unique conditions.
Okay.
And people who believe this theory think that things like superposition, where a particle can be in multiple states at once, are glimpses into these parallel universes.
So with Willow, they're saying the computer's somehow doing calculations in multiple universes at once. And that's how it's solving these problems so much faster.
That's what Nevin's arguing, yeah.
Kind of sounds like science fiction.
Yeah, I know, right?
Yeah. But it's not just some crazy idea. Okay. Like David Deutsch, who's a physicist and a pioneer in quantum computing, has been connecting quantum mechanics with the multiverse for years.
So he was onto this before Willow even came along.
Exactly.
Wow.
He was one of the first to say that quantum computers might be using the power of parallel universes to do calculations.
Wow, that's wild.
Yeah. And his work has really changed how we think about what quantum computers can do.
Yeah, so it seems like what Willow did isn't just about breaking speed records.
Right.
It's maybe revealing something deeper about reality itself.
It's definitely pushing the limits of what we thought was possible.
Yeah.
But it's important to remember that people are still debating what Willow's results really mean.
Right.
It's not like everyone agrees on this multiverse thing.
Of course not.
There are people who aren't convinced at all.
Well, what are the skeptics saying?
Well, there are critics like Ethan Siegel, who's an astrophysicist, and he says that you can explain quantum phenomena without even bringing up parallel universes. Okay, so what are their explanations then?
So there are other interpretations of quantum mechanics, like the Copenhagen interpretation.
Okay.
It's more traditional, And it says that quantum particles don't actually exist in specific states until they're measured.
Okay.
It's the act of measuring them that makes them collapse into a single state.
Oh, I see.
So this keeps everything within our own universe.
Right.
And just focuses on the randomness of quantum events.
So it's more about the uncertainty of the quantum world than about these parallel universes.
Exactly. Yeah.
And the skeptics are also saying that random circuit sampling, while it's impressive, it's mostly a test problem.
Right. It's a benchmark to see what quantum computers can do.
Right.
And they think that eventually maybe classical computers could catch up. even if it takes them a really, really long time.
So they're not dismissing what Willow did.
Right.
But they're saying maybe we shouldn't jump to conclusions about a multiverse.
Exactly.
Don't get ahead of ourselves. So I think we've got a pretty good foundation here, right? We have this amazing thing that Willow did, which seems to be way beyond what classical computers can do.
Yeah.
And we have some people saying it means there's a multiverse, and others saying, hey, hold on, there might be other explanations.
Right. Exactly.
It's a really interesting debate.
It is.
And it really shows how much we still don't know about the universe and what reality is.
Definitely.
Yeah, there's a lot to uncover.
It's fascinating stuff.
Yeah, definitely.
Yeah, it really makes you think.
Yeah, it does. So let's just say for a minute that there is a multiverse. What would that even mean?
Well, it would mean that pretty much everything we thought we knew about the universe needs to be reevaluated.
Right.
Instead of just our one universe.
Yeah.
There could be an infinite number of them, each with different laws of physics, different constants, different possibilities.
Yeah, so you're saying there could be a universe where, like, gravity works differently.
Or
the speed of light is slower.
Yeah, or time runs backwards.
Whoa.
It's mind-boggling.
It is. It is. And if there are infinite universes, are there infinite versions of ourselves out there?
That's a question a lot of people ask. Like, is there a version of you out there that's a famous physicist who understands all of this?
Right.
But seriously, if there is a multiverse, it really changes how we think about ourselves and our place in everything.
Right.
It challenges our ideas of uniqueness, you know? Purpose, even free will. Like, if every choice creates a new reality, do our decisions really matter?
That's a really deep thought.
It is.
But you mentioned earlier that there might be evidence for this multiverse from other areas of science. Like, what were you thinking of?
Well, one area is cosmology, which studies how the universe began and how it's changed over time.
Right.
And there's this theory called cosmic inflation, which is pretty widely accepted now. It explains how the universe expanded so rapidly right after the Big Bang. And this theory suggests that what we can see of the universe is just a tiny bubble inside a much bigger multiverse.
So, like, our universe is just one bubble in a giant cosmic bubble bath.
Yeah, exactly. And then there's something called the fine-tuning problem.
Okay, I've heard of that.
Yeah, so this is about how the fundamental constants in nature, like gravity or the mass of an electron, they seem to be perfectly set for life to exist.
Yeah.
Even a small change in these constants and the universe would be completely different.
Right. There'd be no stars, no galaxies, no us.
Right, exactly.
It's like all the ingredients for the universe were measured out perfectly.
Yeah, like baking a cake.
Yeah, exactly.
And some scientists think this fine-tuning, it's not just a coincidence. They think the multiverse could explain it.
Oh, okay.
They say if there are infinite universes, each with random physical constants, then it makes sense that at least one universe would have the right conditions for life.
So we just happen to be in that lucky universe.
Exactly, like winning the cosmic lottery.
Wow. So is there any evidence for the multiverse from other areas of physics, like string theory or particle physics?
Oh, that's where it gets even more theoretical.
Okay.
String theory tries to unify all the forces in nature, and it suggests there might be more spatial dimensions than we can see.
More dimensions than length, width, and height.
Yeah, exactly.
Wow.
And some string theorists think these extra dimensions could be where other universes exist.
Really?
Yeah, all connected together in a huge multiverse.
That's amazing, but string theory is still pretty theoretical, right?
Yeah, it hasn't been proven experimentally.
So it's an interesting idea, but still a what if.
Right.
Okay, so what about particle physics? Anything there?
There have been some hints.
Oh, really?
From experiments at the Large Hadron Collider.
Okay.
Some physicists think that certain strange things they've seen, like particles decaying in unexpected ways or missing energy, could be signs of particles interacting with other universes.
Like they're slipping in and out of our reality.
It's possible, but it's still early.
Yeah.
We need more data before we can say for sure.
It sounds like we're really at the edge of something big here.
Yeah.
We have these clues from different areas of science.
Right, from cosmology to string theory to particle physics.
All pointing towards this multiverse.
It's exciting.
But we're still looking for that one piece of evidence that proves it.
Exactly.
And who knows what the future holds.
Yeah.
Maybe Willow is the first step towards figuring it all out.
Maybe it is.
So welcome back. We've been talking about some pretty wild stuff, right?
Yeah, definitely mind-bending.
From Willow and its incredible speed to the possibility of all these parallel universes, it's really been quite a journey.
It has.
And now I want to hear from you, the listener.
Yeah, what do you think about all this?
Does the idea of the multiverse kind of freak you out? Or does it excite you?
What really stood out to you from what we talked about?
Do you ever think about, like, infinite versions of yourself?
Yeah, living different lives in other realities.
It's a crazy thought, right?
It is.
Or maybe you're wondering if we'll ever be able to prove or disprove this whole multiverse thing.
Yeah, is it even possible?
What do you think future discoveries might bring?
Will we get closer to solving this mystery?
I think whatever your thoughts are on this,
Yeah,
you're not alone.
a lot of people are thinking about this
The
stuff.
multiverse has been something people have thought about for a long time.
Yeah, for centuries.
And it still makes people wonder and debate.
That's a really big question.
So even if we never know for sure if it exists or not,
Right.
just thinking about it
Yeah,
can change how we see the universe
definitely.
and make us appreciate its mysteries even more.
It's all about pushing the boundaries of our understanding.
So as we wrap up this deep dive,
Yeah.
I want to leave you with one last thing to think about.
Okay.
What if we do live in a multiverse?
What then?
What would that mean for us?
Yeah, for how we see ourselves and where we fit in.
Would it make us feel less important?
Knowing that our universe is just one of many.
Or would it make us feel even more awe and wonder?
Knowing that the possibilities are endless.
These are tough questions.
Yeah, there might not be easy answers.
But they're definitely worth thinking about.
For sure.
Thanks for joining us on this exploration of quantum computing and the multiverse.
It's been a great conversation.
Until next time, keep exploring, keep questioning, and keep your mind open to everything the universe has to offer.
There's so much out there to discover.